Okay, so we're discussing roots of unity, and in particular the nth roots of unity, or complex numbers that satisfy the equation z to the n equals 1. And I mentioned how z equals, and I'm going to call this omega sub n, which equals e to the minus 2 pi I over n, how this is a root of unity that is primitive. And basically, what this root of unity can do is it can generate all of the nth roots of unity. And so, just imagine as an example, if we were going to consider the equation z to the 8th equals 1, okay, what is omega sub n? Well, omega sub n is equal to minus, or e to the minus pi I over 4. And so where is this located on the unit circle? Well, on the unit circle, we can draw the unit circle. So there's the unit circle. E to the minus pi I over 4 is, if we could start from the point 1, 0, we travel an angle of pi over 4 clockwise, and we are here. This point is omega sub n. Now, if we take powers of omega sub n, well, and let me label this also as z. So let z equal omega sub n, so that, and let me erase this omega sub n that I have down here. Let me write z here, and if we square z, if you recall our result that was where we multiplied complex numbers that were given in their polar representation, if we multiply, or if we compute z squared, we get, well, we basically just travel another pi over 4 angles in the clockwise direction. So here is z squared, and so z squared is actually, well, it's minus I. Well, continuing in this fashion, here is z cubed. Oops. So z cubed is here in the third quadrant, located here. Z to the 4th is now on the real axis. Z to the 4th is here. Z to the 5th. Z to the 6th. And here is z to the 7th. I'm having trouble plotting dots here, but you get the point. Okay, so with z we're able to generate all of the other nth or 8th roots of unity. All right, and there's this nice result that's captured in lemma, I believe, 10.1 on the primitive roots of unity. And so this is lemma 10.1. So lemma 10.1, let omega be a primitive nth root of unity. Okay, now it doesn't, and it can be any primitive nth root of unity. It doesn't have to be the omega sub n that I defined previously. Then we have the following result. So if we sum from j equals 0 to n minus 1 omega to the jk equals, well, it's n if k divided by n is an integer, and 0 otherwise. And that's what the OW stands for, otherwise. So this is called the Fourier Transform identity. And now I will ask the question, well, why? Why is this so? Okay. We'll consider the case k equals 1. And so now let's see what the sum gives us. So the sum is 1 plus omega plus omega squared plus dot 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 plus omega to the n minus 1. Okay, and I'm going to say this equals 0, and I'll ask why. Well, it turns out that if we consider the difference of y minus omega sub n, okay, this equals, all right, if we factor, and if you think about the finite geometric series formula, which is 1 minus omega sub n, I'm sorry, 1 minus omega to the nth power divided by 1 minus omega, what does that equal? Well, I'm going to actually multiply by 1 minus omega, and what does that equal? It equals 1 plus omega squared plus dot 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 plus omega to the n minus 1. Okay. All right, so this comes from, like I said, this is a finite geometric series formula. Okay. And, well, what is 1 minus omega to the n? Since 1 minus omega to the n equals 0, and omega does not equal 0, I'm sorry, omega does not equal 1, we get the results. We get the result. So I'll just say that the result follows. And now if we consider so I'll say a similar result follows if k is equal to 2, 3, and so on until n minus 1. Okay. But what happens if k actually equals n? So I'll ask the question, what if k equals n? Well, if k equals n, we have 1 plus omega to the n plus omega to the 2n plus dot 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 plus omega to the n minus 1. And this equals, well, what is omega to the n if omega is an nth root of unity? Well, omega to the n is just 1. Okay. So we get 1 plus dot 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 plus 1. How many 1s are there? There are n of these. Okay? And so the result follows from this analysis.